All right, our unit goal is the first one, modeling. Understand exponential graphs of the form y equals ab to the x minus h plus k. Our daily objective is to explore the properties of functions of the form y equals ab to the x. And our lesson is 7.2 from the book, Properties of Exponential Functions. Our first problem, how does the graph of y equals negative 1/3 times 3 to the x power compare to the graph of the parent function? The first thing we need to talk about is what a parent function is. Parent function is, remember, the most basic one. So if I'm looking at this function, this is a couple things combined. The most basic function, though, would be y equals 3 to the x. So the first thing we're going to do is just consider what if our equation was y equals 3 to the x, because that is our parent function. So if I put some values in for x, let's say I'm just going to try out our normal -2, -1, 0, 1, 2. Then I get y equals 3 to the -2 power, and 3 to the -2 is 3 to the second, but on the bottom, so it's 1/9. This one would be 3 to the -1 power, which is 3 to the first, which is 3, but I'm going to put it on the bottom because it was a negative exponent. This is 3 to the 0. Anything to the 0, remember, is 1. 3 to the first is 3, and we know 3 to the second is 9. We should be able to fill out that part of the xy table pretty easily. Now, the actual equation that they gave us was -1/3 times 3 to the x. So what I'm going to do for these is I'm going to do -1/3 times 3 to the -2. Well, 3 to the -2 was a 9th. So when I take -1/3 times that, I get -1/27. Then if I do -1/3 times 3 to the -1, which was 1/3, I get -1/9. On this one, I will take -1/3 times our answer from over here, which was 1. -1/3. This one I'll take -1/3 again times our answer, which was 3. That was a really nice 3. And we get -1. And then if I take -1/3 times what 3 to the second was, 9, I get -3. So if I plot these ordered pairs, first I'm going to plot these ones. So -2, 1/9. So -2 up just a little bit. Then -1, 1/3. 0, 1, 1, 3, 2, 9. So there's the parent function. Okay? Then if we want to graph these ordered pairs, I'm going to do this x, -2, and this y, -1/27. That's just slightly above 0. -1, -1/9. Oops, sorry. I should be on the negative side here. Let's try that again. -2, -1/27. That's right here. -1, -1/9. 0, -1/3. 1, -1. 2, -3. So the question they were asking is how does the graph of the blue one compare to the graph of the red one? Well, if we look at the numbers here, when we got 1/9, we got -1/27. When we got 3, we got -1. When we got 9, we had -3. So if we just look at the graph, it's been flipped. And you'll notice that if this was 9 and this was -3, the numbers are 1/3 as big. Which means this graph has been compressed. been shrunk together. Where do we think this comes from? I bet you this negative is what flipped it, and the 1/3 is what compressed it or made it scrunched up. Let's look at another example. How does the graph of y equals 2 to the x minus 4 compare to the graph of the parent function? Again, the parent function is the more basic one that you can kind of see in here. In this case, y equals 2 to just the x. So here's my parent function. We're going to do the same thing where we just look at those values first. -2, -1, 0, 1, 2. So I have 2 to the -2 power, which is 1/4. 2 to the -1 power is 1/2. 2 to the 0 power is 1. 2 to the first is 2. 2 to the second is 4. Before we go any further, let's graph those this time. So -2, 1/4 right here. -1, 1/2. 0, 1, 1, 2, 2, 4. Let's go one more. Maybe if I have 3, 2 to the 3rd power is 8. So 3, 8. Okay, so there's the graph of our parent function. Whoop. Let's shift this guy down a little bit. There we go. Now, if we're going to change over and look at these, we're going to go 2 to the -2 minus 4, which would be -6. So I'm just plugging -2 in right here. And that becomes 1/64. Very small number. Then we have 2 to the -1 minus 4, which becomes -5. 1/32. 2 to the -4 is 1/16. 2 to the -3 is 1/8. 2 to the -2. 1/4. We're still dealing with a lot of fractions here, so I'm going to extend this chart a little bit. 2 to the 3 minus 4 is -1. It's 1/2. What if I go to up to 4? That becomes 2 to the 4 minus 4 is 0. Let's go 5. Be 2 to the 1st. There we go. We finally got some whole numbers here. So let's go -2, 1/64. That's going to be right here somewhere. -1, 1/32. Again, right there. 0, 1/16. These are tiny numbers. 1, 1/8. 2, 1/4. 3, 1/2. 4, 1. 5, 2. We get 6, 4, and 7, 8 if you were to keep that chart going. And here's the graph of that line. So the question was, remember, how does the graph of the blue one, y equals 2 to the x minus 4, compare to the graph of the parent function, this red one? Well, if I look at each of my dots, I notice it's the same shift over every time, even down in these itty-bitty ones. And how much did it shift over? 1, 2, 3, 4. So it shifted 4 to the right. So what I want you to look at is just this bottom one right here. This is the most generic form of our exponential functions. This x minus h up here, if you see something in the parentheses like this, this is your indicator that your graph is moving left and or right, depending on if it's positive or negative. Just like all of the other shifts we've had this year, left would be positive and right would be negative. It's goofy. This plus k right here is our up and down shift. Again, just like we saw like with absolute value, plus is up, minus is down. And then this a number here is kind of our stretch or compress number. And that just tells us if we're going to make the graph stretch out more or squish it up. So stretch and compress, left and right, up and down. Those are the three different things we could do to our exponential graphs. Sometimes when you open a bank account, they have what's called something that's called interest that's compounded continuously. And if they have that, this is the equation that you're going to use. So A of t equals P, which is the principal, and I like to say what you put in, or the starting amount. Then E is a constant on our calculator. It's kind of like pi. You can find the E button on your calculator for the most part, and if you can't find it, it's just 2.72. So that's a number. E is a number. R is the interest rate, and again, you want to change that to a decimal. And then T is time, and make sure it's in years. So let's give this a try. You put $3,000 into an account that pays $5,000 annual interest compounded continuously. How much will you have in the account 4 years later? Okay, so we need to identify all of our amounts. $3,000 is what you're initially putting in, or your principal. So I'm going to go A of 4, the amount after 4 years, is what you put in times E, and I'm just going to leave it E for now. R is your interest rate. If we have 5% interest rate, we're going to change that to a decimal by moving that decimal place back 2. So we're going to do 0.05, and then times T, which is your time in years. They said 4 years later. So we're going to put 4 in here. Now you'll clean this up a little bit before you grab your calculator. You're going to do 3,000 times E to the, when I multiply these two, I get 0.2. Then you want to make sure you're doing this in the right order on your calculator. You're going to go E to the 0.2 power, hit enter, then hit the times 3,000 because exponents come before multiplication. And when you do that, you should get $3,664.21. Now this number is going to vary a little bit depending on whether you use the E button or you chose to use 2.72. I used the E button. So if you try this on your calculator and it's just slightly off, that's probably why. And that's it. That's how much will be in your account 4 years later. Okay, your assignment today is page 447, numbers 7 through 15. I do want you to make an XY table to graph those. And then when you get to 16 to 21, I'm changing the instructions from what they say in the book to make it easier. All I want you to do is identify the parent function and tell me how it's been translated. So it's been shifted up or down, left or right this many, or if it's been stretched or compressed. You don't need to graph, so no graphs on 16 to 21. And then obviously 28 to 30. And that's it.